So I'm Francesc Campoy, and as Mark mentioned, I used to be at Google, but at the Go team, and then I left, joined a different company, and then I left and joined a different company, and now we're building a cool thing that I wanted to talk about. So the title of the talk is Badgers, Gophers, and Graphs, and they're actually somehow related. So this is a badger. I think we all know that badgers are fast, and badgers are cute, and this is a gopher. And gophers are fast, and gophers are cute. Also, this badger is called Diggy. And what's the name of that gopher? No, there's no name. Yeah. I know, it's weird. Some people call it Gordon, but that's wrong. So, it's just wrong. So, yeah, but also, and guess what? That's a graph, right? So, badgers, gophers, and graphs, they're all related in a couple of ways. Badger is actually also one of the products that we're creating. It's an open source, completely open source embeddable key value store, fully written in Go. So it's something a little bit like RocksDB. And it is really cool, really powerful. And thanks to trying to release this, I actually ended up hating Go modules. So, you know, it's a very interesting project. Yeah, lots of fun. And it's all online. It's written in Go, Apache v2, so you can use it anywhere where you want. We have a bunch of users, which is really nice. On the other side, we also have Gophers, and as you know, great language to write a bunch of different things, but specifically it's really good for everything that is distributed systems. That's why, you know, Docker, Kubernetes, they're all written in Go. There's very good support for concurrency, very good support for networking and all of these things, which makes it a very good choice. So with these two things, we built something together, which is something that supports graphs. And I'm not gonna get into graph theory, because, yeah, so I'm just gonna say graphs are things where you store nodes that, depending on how fancy you are, you might call them vertices or facts or whatever you want to call them. And then you have predicates or relationships, right? So here when I'm saying Badger is fast, Badger is a node, fast is a node, and is actually a relationship that is actually tying those together. There's many ways you can model data, but the good thing is that in general, when you're writing something like this, if you go to a whiteboard, you're gonna end up writing something similar to this, right? Like the idea is you have this data, and now you wanna store it in a database. The first thing you're gonna need to do is how do you convert this into a SQL table? And it's not that fun. So instead what we do is we just store the graph directly, like this. So the name of the project is dgraph, and the D stands for distributed, I think. I'm actually not completely sure. Yes, okay, I was like, he's there, yes. So yeah, it's there, it stands for distributed. It's completely open source, it's written in Go, it's powered by Badger, it also uses Raft, the algorithm to decide leadership, etc. Uses gRPC and a bunch of other open source packages. So it's everything open source, we all love open source. It's also on GitHub, and you should check it out. So, now let's see what it looks like. And fun thing, right before I go on stage, this stopped working. So let's see. Yeah, it's still not working. But that's fine, that's actually, on Safari it's working, but it stopped working on Chrome. Just so you know, that's an issue right there. Okay, so the cool thing is that instead of, if you've ever heard about the graph databases, you might have heard about things like Cypher or Gremlin, these graph query languages. Instead, what we're using is GraphQL. So it's not GraphQL exactly. We have GraphQL plus minus, because it's not a superset, it's a similar set to GraphQL. So let's check, for instance, let's check function, where's anyone that has a name in English, which is Kevin Bacon. Let's go, Kevin Bacon. And I'm gonna get its name. You run this, and you get 2 Kevin Bacons. Okay, I want the one that is actually an actor. So I'm gonna say, filter this, and get me the ones that has an actor dot film. Cool, that's awesome, but I wanna know also the name of the movies that he's been into. So I'm gonna do actor film, and then performance dot film, and then I get the name. So now I'm getting a bunch of names of movies where he's worked before, right? This is cool. Jason is, you know, cute, but I actually like this a lot. So you can actually display the graph and go into it. The interesting thing about this is that you can find things that you might not even see directly into JSON, because you can actually expand nodes. So you can say here, let's see, Mystic River, tell me more about it. And now you've been loading all the data around. So it's a very nice way to even explore your data set. Oh, that's a graph database running on Mac, runs on Mac. I do not recommend it running on Mac while you left all of your cluster from the Kubernetes session, because that was not working. It is gone now. Yeah, so there's a bunch of queries that you can do. The one I wanted to do, I don't have enough time, so we're not going to do that. So instead, we're going to do something else. Oh, yeah, I know what I wanted to show you. So initially, what I wanted to find was someone named Badger, which, there's people named Badger, so you can do, there's indexing and everything, so you can do any of terms in the name is Badger. So you can find people called Badger if you get the name. Let's see, all of those people are called Badger, Clarence Badger, etc. But I actually thought it was better to find someone called Gopher. There's no humans called Gopher. But there's this guy, Gopher Goofy, which I love the name. I didn't know anything about it, so I click in there. And I actually figured out that he was part of the Looney Tunes. So I didn't know there was a Gopher in Looney Tunes, but I learned stuff. Last but not least, so yeah, we have index-free adjacency, which is what makes this possible and go so fast running around a graph rather than having unions. We support GraphQL. We support GraphQL Plus, actual GraphQL soon. And also, we have a bunch of other features that I have to talk about. The cool thing, we have a bunch of clients. It's based on gRPC, so these clients use gRPC mostly. For those that might not know what those are on the left, right side,